Utility is the measure of satisfaction. Units code. Utils are illustrated by the curves code in different scales. These in different scales are parallel to each other. The different scales do not crisscross. The different curve on the right offers higher utility compared to that below it. Then indifference curve IC2 has the highest utility or the most optimal utility. What this means is that A, you're performing below the budget. At C, you're in an unattainable condition. It is impossible because that is above your budget. At B, you're optimal. Point B is called the marginal rate of technical substitution. This is the optimum bundle. This is where an individual gets to maximize their satisfaction. So this is how indifference curves look like. They are concave about the origin. They give the origin the back. So we're going to dominate on the following formulas. There's what we call the budget line formula, which is given by income is equal to price of good X times X plus the price of good Y times Y. The utility 1 and utility 2 difference will give you what is called the lambda. The lambda simply is the impact of an increase in a budget by 1 kwacha. So if your husband has been promoted and was getting 1,000 and now is getting 1,001 kwacha, it means the increase by 1 kwacha has a multiplier effect. That is called lambda. So lambda times the price of X gives you the marginal utility optimum for X. The lambda multiplied by Y gives you the optimum marginal utility at Y. Then if the marginal utility of X divided by the price of X is equal to the marginal utility of Y divided by the price of Y, that is the optimum bundle. Utility is usually expressed in terms of X and Y, good X and good Y. So I'll start with utility 1 and then utility 2. But before I go any further, there's what we call MRS. This is the marginal rate of substitution. How many units of good X can I substitute for good Y? For instance, good X is Fanta and good Y is Coke. And Fanta is 2 kwacha, Coke is 4 kwacha. How many Fantas make a Coke? How many Fantas make a Coke? 2. Any questions this far? Okay.
Collins, I've got a question. Yes. Which formulas are we supposed to master, considering that there are about 17 formulas? Are they going to be applicable in the exam, or the formulas?
No. I will give you the formulas you look at during revision. For now, I just want you to understand the concept. These formulas are not given, but they're easy. For economics, we're looking at the principles more than just the formulas. So in this case, you will not have to master, but you need to know. So I'll show you how these are applied. Let me take you through a question. You see what I mean. Mr. Banda has 100 kwacha to spend on 2 goods, X and Y. Good X costs 10 kwacha and good Y costs 40 kwacha. If the budget increases from 100 kwacha to 101, his utility will increase from 4.0 utils to 4.05 utils. So already the difference from 4 kwacha, from 4 utils to 4.05, that difference is called lambda. Good X has a budget of 100. So that is our I. So first question is find the optimization problem. The optimization problem is simply the budget line, which is given by the income is equal to price of X times X plus price of good Y times Y. So our income here is what? 100 kwacha. So you put 100 kwacha here. Good X is 10 kwacha. So 10X. Good Y is 40 kwacha. So 40Y. So this is 5 marks, giving you the formula of the budget line. Is that clear? Then the second part is find the Lagrangian multiplier. Like I have said, the Lagrangian multiplier is simply the difference between the second U-tau and the first. So it increased from 4.05 to 4.00. So the difference in the U-taus, that is called your lambda, which is 0.05. And what is the marginal utility at optimum for X? Just multiply the lambda times the price of X. The 0.05 multiplied by 10 kwacha, we're going to get 0.5 U-tau. For the marginal utility of Y at optimum, you multiply the 0.05 times the 40 kwacha, which is 2 U-taus. So this is how we find MUX and MUY. Then we are asked, how do we find the marginal rate of substitution? They'll start with X for Y and Y for X. So if they start with X for Y, you start with the price of X over price of Y. So this is negative 10 over 40. We get negative 0.05. If they say Y for X, you start with the letter that has been first discussed. So negative Y over price of X, so which is negative 40 over 10, which is negative 4. The negative comes in place because you're exchanging one good for the other. How many units of X are substituted for Y? So Y is costing 4 kwacha, X is costing 10 kwacha. So how many units will be substituted Y for X? So it will be 4 units. And the slope and the marginal rate of substitution of X for Y is the same formula, negative PX over PY. So our slope is negative 0.25.
Sorry. Hello, Collins.
Yes, please.
Yeah, just a question. So let's explain the marginal rate of substitution for XY. So which good are we giving? Are we forgoing for the other one?
We're substituting with
marginal
X
rate of
for Y.
substitution
Yes.
of
We're
XY.
as they are appearing in the grammar, we're substituting good X for Y. The marginal rate of substitution, how many units of X can we substitute for Y? Yes, how many units of Y can we substitute for X? Okay. Since X is 40 kwacha, Y is 40 kwacha, X is 10 kwacha. So we're going to substitute, in short, 4 units of X will make 1 unit of Y. That's what it means. How many units of Y substituted for X? So 4 units of X make up a Y. That's in other languages what it means. Then they'll ask you, what is the impact of increasing the budget by 1 kwacha? So lambda explains the impact of increasing your budget by 1 kwacha. So it means if we increase our budget by 1 kwacha, our utility will increase by 0.05. That is the implication. Are we together? Okay. And we now go to calculus. So I'm going to dominate much on this utility using calculus tomorrow as I look at production using calculus, because those of you who haven't done dy dx, I think will be a little bit lost unless all of us are comfortable. Is there anyone who didn't attend my calculus class here?
I didn't.
You didn't? Okay. So I can set how we go to production 1. Before I go to utility 2 and production to the parallel. So for production, you need to understand that what is production to start with? Production is a conversion of raw materials into finished goods. The raw materials, in this case, are inputs in terms of labor and capital. The labor is denoted by the letter L, and the capital is denoted by the letter K. The reward for labor is, yes, please.
Hello,
Yes, please.
utility 2, you've explained.
I'm saying utility 2 and production 2 will be explained tomorrow after you learn calculus, because this is dependent on calculus. So there's one person who hasn't learned calculus. So I'll do that tomorrow.
Okay.
I'm going to do utility 1 and production 1, then we are done for today. So production is a conversion of raw materials into finished goods. The raw materials, we have labor and capital, for whose reward are wages and rent. The reward for a labor unit is a wage. The cost of procuring capital, like machinery or human capital, is rent. So production output is denoted by the letter Q, and the function is given in terms of labor and capital. So if you differentiate dQ over dL, we call that the marginal product of labor. dQ over dK, that's the marginal product of capital. When we divide the marginal product of labor over the wage, the marginal product of capital over the rent, this is called the optimization bundle for production. Like was done with utility, production also has curves that are concave. The curves joining lines that offer the same production are called isoquants. Does anyone remember the curves that join points that offer the same subtraction? What are they called? Indifference curves. So the properties of isoquants are so similar to those of indifference curves. Number one, they are concave about the origin. They are parallel to each other. They don't crisscross. They are optimal at point B. This is called point B. At point A, we are underutilizing resources. At point C, we are unattainable. At point B, that is the point where the indifference, the isoquant kisses the budget line. And now the budget line is given by cost is equal to rent for capital and wages for labor. This point is called MRTS, marginal rate of technical substitution. So the formulas under production are as follows. So the Q is also denoted by the total product of labor. TPL is the same as the total output. The total product of labor divided by the labor unit is called average. The average product of labor is APL. If we divide it by capital, TPK is the total product of capital divided by the capital units. We call this the average product of capital, APK, not L. When you're differentiating the output with respect to labor and capital, the Q over the L is called the marginal product of labor. It is simply the change in total, the total product of labor divided by the change in the labor units. When we go to our output with respect to capital, we call that the marginal product of capital. We call that the marginal product of capital. So I will send these summarized notes on the paid up group. So when we are dealing with marginal product of capital, we want to calculate how much additional units, any additional units are called the marginal product. It can be of labor, can be of capital. If we multiply them with the price, market price, we get what is called the marginal revenue product, which is the amount of the labor units or capital units in terms of money. The wages or the cost of procuring human capital or machinery is called the marginal resource cost. whenever you're employing any capital, whether labor or machinery, you're only getting a marginal benefit if your marginal revenue product is more than the marginal resource cost. When you apply the average product of labor times the labor units, we get the total product of labor. We're going to look at an example again. Okay. So here we're given a question where a firm has 10 workers. These workers have an average product of labor, which is 1,000, and the market price is 2 kwacha. Additional units are being considered where we want to employ an additional worker, and this worker is bringing in 900 additional units. So let's analyze this question. A firm has 10 workers. So 10 stands for the what? Laborers, L. And these laborers have an average product of 1,000. So APL, which is the average product of labor, is 1,000. The market price P is 2 kwacha per unit. The additional units that this laborer brings are 900. So this is the marginal product. Anything additional is called marginal product. So now, before I go into the nitty-gritties of this question, we are 5 of us today. So suppose the 4 of you, each one of you in a company is producing 1,000 units. What is the total product that is being produced by the 4 of you?
4,000.
4,000, good.
Is it?
Suppose I want to join you and me, I'm contributing 6,000 units. How much are we going to have? The 5 of us?
$4,600.
4,000 plus 6,000. I'm bringing 6,000 and you have 4,000. What are we having in total?
10,000.
10,000, good. But what is the average for this 5 of us? We divide-
2,000.
Good, we divide the 10,000 divided by 5 to get 2,000. That is the average. Now, if I am bringing in 6,000 and each unit that I'm bringing in is worth 2 kwacha. So the marginal revenue product I am bringing in is 2 kwacha times my 6,000 units. So meaning I am bringing in 12,000 worth into the business. And if I'm asking for a salary of 10,000, am I worth being an employee? Yes, because I'm contributing a marginal benefit of 2,000. But if I'm asking for 15,000, I'm unattainable because I'm asking for more than I am bringing. So let's just start the question. So let's go back to this question here. A firm has 10 workers. They have each an average of 1,000. Each unit is 2 kwacha. So just at that point, the laborers are 10, the average is 1,000. The price is 2 kwacha. We want to bring in an additional worker who's adding 900 units. So firstly, what is the total product for the 10 laborers? We multiply 10 times 1,000, we get 10,000. This is the total product for 10 laborers. But if one person is supposed to join us, we're going to be 10 laborers. So we're going to have 10,000 plus 900, we get 10,900. What is the new average if this person has to be taken on? So we divide the 10,900 divided by 11 laborers. So we have 909.09. Second question is, what?
Just a minute. Sorry, Collins. Just go up a bit again. The other, yes, there. Okay.
So the second question was, the first question is, what is the new average if this worker is employed? The second question is, should the employee be paid if he's demanding? Should the employee be hired if he's demanding for 2,000 kwacha or if he's demanding for 1,500? So for us to know how much to pay this person, first we need to know the marginal revenue product, the worth of his additional units of 900. So when we calculate the additional units of 900, they're giving us 1,800. So if you're going to compare these two prices that he's asking for, if he's asking for 2,000, he's asking for more, we can't afford it unless it's an expatriate. But if he's asking for 1,500, he is worth keeping because he's what? He has a marginal benefit of what? He has a marginal benefit of how much?
300.
Of how much? How much? Okay, so now
Be 18 minus 15, 300.
300, yes. Okay, so now let's go to the tablet. Okay, so let's look at the situation where somebody is being fired. So we have this company here. Let's think together. The company ABC has average of, let me copy this on a separate page so that we can discuss properly. I want us to participate, please. Participate. This is a straightforward question. Okay. So you tell me what you've seen. The company is operating at an average of 1,000 units with its current 10 workers and is considering firing one worker whose marginal product is 1,300. What is the average product after this worker is fired? So let's identify. What do we have? Average product. What are we given here? Average product is what?
1,000.
1,000. And the number of laborers?
There are 10.
So when you apply this one times the 10 laborers, what do we call this? The total product of labor, right?
The total product of labor.
So what is the total product of labor?
It should be 10,000.
10,000, correct.
Yes.
What else are we taught? This is for 10 laborers, right? What else are we
Yes.
taught?
We're told that it's considering firing one worker whose marginal product is 1,300.
So when we fire one, what would be our total, or how many laborers would we have?
9.
We'll have 9.
9. So the marginal product of labor, so in this 10,000, we have 10. But if you remove one person who has how much? 1,300. What are we going to remain with?
Will remain 1,300 from 10,000.
What do we get?
8,700. 8,700.
8,700. Correct. So what will be the new average product if we fire this person? What are we
Just a
dividing?
minute.
8,
The
7
8
divided
7
by
would divide by 9.
Yes. Why are we dividing by 9?
we remain with 9.
Because we remain with 9 laborers. Correct. So what becomes our new average product?
Nine 966.67.
966.67. So this is how much we're going to have when we fire one person. The average will reduce from what? From 1,000 to 966. Now, that being fired was being paid a wage of 3,000. His marginal product was 1,400, and the market price was 2 kwacha. Was he worth being fired? What do we need to calculate for us to know whether it was worth keeping or worth being fired?
He was worth being fired.
We need to first know the marginal revenue product. It must always be greater than the what? The cost or the wage
The cost.
or the marginal resource cost, right? So how do you find the marginal revenue product? It is the marginal product
Marginal product
times
is
what?
equal to marginal product times price.
Good. And what was the marginal product? Marginal
The
product
marginal product was 400.
4. Good. And the price?
The price was 2 kwacha per unit.
And how much was it bringing?
That would be 2,800.
It's more than how much
Yeah.
it's asking for?
3,000. Marginal price.
He was asking for 3,000. So he was worth being fired, right? Because what he was asking for was less than what he was paid. So this is a justification to that. This is a justification to that. Okay, lastly, we have a company that has workers that are employed. And these workers, we want to ascertain whether they're optimally being employed or not. So we're given the following details. Number one, we're told that there's good what? There's worker X and Y. So ABC has employed 2 workers, X and Y, in such a way that their marginal productivities are 10 and 7.5 respectively. What are we given? The marginal product of X, the marginal product of Y. What is the marginal product of X and marginal product of Y?
At 10
X is 10,
and Y is 7.5.
Y is 7.5. Then we're told that the wages for X and Y are 6 and 4. So what is the wage for X
6 kwacha.
and Y?
It's 4 kwacha.
Under production, how do we know that the people are optimally employed? What is the optimal combination?
We were for the wage, just a minute.
The marginal product of X divided by the wage for X must be equal to what?
Y.
Marginal product
So
of
the marginal product of X, we divide by the wage of
Okay.
X. Is equal
over
to
the marginal product of Y divided by Y. These must be the same. So here we have what? 10 divided by 6 must be equal to what?
7.5 divided by 4.
Divided by 4. So what are you getting?
1.67. 10 divided by 6 is equal to 1.67. And 7.5 divided by 4 is equal to 1.875.
Are they optimal?
No.
Optimally employed, they're supposed to be the same. So you need to understand the concepts surrounding the optimum bundle. So I gave you this in the note to understanding where optimal bundles exist. So we'll end here for now. I'll give you some homework based on what we have covered.